The simplest way to start using pointers is to get the address of some variable. I can define a local variable called apples. This variable is stored on the stack, in memory, and you don't have to think about where or how it's stored or how its storage was provided, but you can get its address using the address of operator. That's the ampersand, which is a unary operator that I've not yet introduced, and has nothing to do with the bitwise AND operator, which, as you know, is a binary operator. The address of operator returns the address of some object. In this case, the object that the apples variable refers to. I then use this returned address to initialize the p variable, giving it an initial value. The asterisk, or star, following the type and preceding the pointer variable name indicates that this variable, which is also stored on the stack, is a pointer to int, or a pointer variable storing the address of an integer object. Again, this star has nothing to do with the arithmetic operator. Now, pointer declarations can get complicated. This is really simple, but as you will see later, it doesn't always stay this simple, and I've found that it helps to read such declarations from right to left. Start with the name of the variable and move back until you reach the beginning of the declaration. When you see the star, just say pointer. So p is a pointer to int, and it's initialized with the address of the apples variable. Now we see another use of the star, and in this case it is another unary operator that returns the contents of its operand. This is often called the dereference operator, as it dereferences the pointer, returning the variable being pointed to. So here we see an expression, and you can read it as the contents of p plus 6. The result of this expression is then used to initialize the oranges variable, giving it an initial value of 11. Now, a key insight to remember when using pointers is that the compiler is usually unable to detect whether pointers are in fact pointing to some valid location. C also does not offer any runtime facility for making these sorts of checks. Consider this scenario. We have already learned that local variables are not initialized, so the value of the p local variable, or the address that it initially points to, is not predictable. It could be anything. So when subsequently executing this line, what happens? Well, nobody knows, and this is where pointers get ugly, because your program will just go on and treat the contents of the address being pointed to as if it is an integer. Assuming the address is in an addressable range, your program may continue to run without realizing that its results are quite likely incorrect and poisoning the rest of your program and the user's information. A much better scenario is if the p variable is initialized to 0. In this case, you can be sure that your program will crash very abruptly. What that means depends on the OS, but your program won't simply continue running, causing more harm. Obviously, some defensive programming will go a long way. Given that we all agree that a null pointer is an invalid pointer, and null is represented by 0, and 0 is treated as false in C, we can simply use an if statement to check whether the pointer points to anything before using it.